Welcome to this presentation of Course 2, Module 9, covering First Hop Redundancy Protocol Concepts. In this module, we'll go over the purpose and operation of First Hop Redundancy Protocols, and we'll take a closer look at how Cisco's proprietary hot standby router protocol operates. We'll also use Packet Tracer to illustrate this technology in action. So let's begin. End devices are typically configured with a single default gateway. If a default gateway router fails, then the LAN loses connectivity to any outside networks. First hop redundancy protocols provide a way to have an alternate default gateway to be configured on a network. This provides a redundant backup should the default gateway link go down. First hop redundancy is defined as the ability of a network to dynamically recover from the failure of a device acting as a default gateway. One way to prevent a single point of failure at the default gateway is to implement a virtual router. Multiple routers can be configured to work together to present the illusion of a single router to the host on the LAN. By sharing an IP address and a MAC address, two or more routers can act as a single virtual router. The IPv4 address of the virtual router is configured as the default gateway for the workstations on a specific IPv4 segment. When frames are sent from host devices to the default gateway, the host uses FHRP to resolve the MAC address that is associated with the IPv4 address of the default gateway. The FHRP resolution returns the MAC address of the virtual router. Frames that are sent to the MAC address of the virtual router can then be physically processed by the currently active router within the virtual router group. In the bottom diagram, it shows a link failure, either by a router or the link itself. The standby router stops seeing hello messages from the active forwarding router, then assumes the role of the forwarding router. Because the new forwarding router assumes both the IP and MAC addressing of the virtual router, the hosts see no disruption. There are some different options for using this technology. HSRP, or Hot Standby Router Protocol, is the one that Cisco most wants you to learn. It is a Cisco proprietary FHRP. You'll also want to be familiar with the other different options on this list, especially GLBP, which is another Cisco proprietary protocol, and it provides load balancing within a group of redundant routers. And this module focuses on HSRP. HSRP is used in a group of routers to select an active and standby device. The active device is used for routing packets. The standby device serves as its backup. The standby router monitors the operational status of the HSRP group and quickly assumes packet forwarding if the active router fails. HSRP uses an election process to determine which router is the active router and which is the standby router. By default, the router with the highest IPv4 address is elected as the active router. However, if an administrator wants to specify which router is active and which is the standby, that can be configured by specifying the standby priority for each router. The router with the highest standby priority becomes the active router. By default, after a router is elected as active, it will remain the active router even if another router comes online with a higher priority. In order to overcome this, you must use the standby preempt interface command on the router with the higher priority. This will allow that router to trigger the re-election process and assume the role of the active router. This is a table of HSRP states. You should become familiar with this. I believe there's a test question. Basically, the initial state, that's the state that it boots up in. Learn, that's when the router has determined the virtual IP address but has not seen evidence of the active router. In that state, the router just sits and waits to hear from the active router. this list is on the book, so just go ahead and take a look at this when you have a moment and just kind of memorize these states. And there is a packet tracer assignment in this module in section 9.3.3, which we're actually going to walk through here. And bring this over. And we're going to skip part 1, which is just verifying connectivity. If you do this on your own, you can do that as well. And I would encourage anybody to do this on their own, just so you can become more familiar with how this technology works. So let's configure HSRP on R1. It's on gigabit 01. Use standby version 2. We'll assign the virtual IP address. We're going to have R1 be our primary default active router. So we'll set its priority higher than 100, which is the default value. Set it to 150. And because we want this to be the active router, we're going to do the standby one preempt command. What this basically does is it makes sure that if this router goes offline, although the standby router will take over, when it comes back online, it will reassume the role of the active router. And help if I spelled it right. Okay, now we'll configure R3. Now this it's actually gigabit 00 for this one, right? Yeah, it's gigabit 00. We need to specify standby version 2 and specify the virtual router IP address. We don't need to set the priority for this because we're going to leave this as a standby router, so it will have a default priority of 100. And it's already reached its state of standby. If we show do show standby on R3, shows state as standby, shows the active router is 192.168.1.1, which is the physical interface. We can take a look at R1's configuration, do the same thing. this is the active router, and it shows the standby router as 192.168.1.3. Okay, so let's change the default gateway for our hosts. And it's going to be the virtual router IP address. And let's see, in part 3, it says specifically to open up traceroute. On B, I'm going to traceroute to the web server. Okay, so it's going from to R3, as you can see. Looks to be it's on R1. To R2, from here to here, and then out to the web server. Remember that before it was set up to go through R3 was the default gateway. So now it's going to R1, so it's going to the priority, to the router with a higher priority, it's R1. All right, so let's break the link to R1, and we'll do the same thing and see what happens. And notice in Packet Tracer it took a moment to resolve, but it is going now to R3, and then to R2, and then up out to the web server. We do that trace route again, it'll probably be a lot cleaner. Yep. And now let's restore the link. And now it's going back to R1, and then R2, and out to the web server. So it dynamically, when we took down the default gateway, it dynamically changed to use R3 as the default gateway, which is the standby router. And then when R1 was put back online, R1 reassumed the active router role. And that is how first hop redundancy protocol works. All right. And thank you for joining us today, and you have a great day.